Here we go.
Hi, I'm Caroline Richardson, and welcome to Make the Grade. Make the Grade is an EOC review process that's going to help you be much more successful on your EOCs this season. You can call in with questions with a number that will appear at the bottom of the screen, or you can email. And if you need to find the questions, go to the Wake County website at www.wcpss.net, and you'll see the list of questions. Okay? We're going to get started today with some Algebra 1, which I think you'll enjoy. And since you may or may not have the questions in front of you right now, I'm going to go ahead and look at question 1 for you. The goal, the learners to perform operations with numbers and expressions to solve problems. That's pretty big and open-ended, so we're going to narrow it down. First goal, to write equivalent forms of algebraic expressions to solve problems. Okay? So problem 1, express in terms of x the mean of 4x squared minus 6, 2x squared plus 4x, and negative 13x plus 3. Now there's a couple things you're going to have to remember on this. First of all, what does express in terms of x mean? Well, that means your variable is going to be x, okay? And the second thing you need to remember is what is mean? Now, since I'm just the one talking, mean normally is when you have your data, add up all your data, and you're going to divide by the number of data that you have, right? Like you're taking your average of your test scores. You had 3 tests, you'll add up your tests, you add up your 3 tests, divide by 3, okay? So if we look at the 3 terms that we have, and I'm going to put this off to the side and just write them up here. We have 4x squared minus 6. We have 2x squared plus 4x, and we have negative 13x plus 3. Now, one of the things that often causes problems is you're not combining like terms. So what I like to do to make things a little simpler is when you line these up, do regular addition, like when you used to do it horizontally versus vertically, and line them up in such a way that all of your variables are accounted for. Okay? So I have a column for the x squared, a column for the x, and a column for just the coefficient, or the no x's actually. So then the second one, negative 2x squared plus 4x, and then there's just nothing for the whole number, and negative, or 0x squares for that one, plus a negative 13x. I'm just going to switch to make your life easier. Okay? Now you can add just like you used to do. So negative 6 plus 3 would be negative 3, 0, 4, and negative 13. Is going to give us negative 9x, and 4x squared, negative 2x squared is going to give us 2x squared. So, next thing you have to be careful is I bet that's going to be answer A on the EOC, but you're not done. The question said, find the mean. You always have to go back and look at what the question's asking for. So that wants us to do what? It wants us to divide by 3. I added wrong. Are you watching me? That should be a 6. I've got to carry my numbers over. That should be 6x squared. So now we're going to divide by 3. Now, with division, you have to be sure you divide everything. Can't break up the family. Got to always keep the family together. You divide it with everybody or nobody. So 3 goes into 6x how many times? 2x squared. 3 goes into 9x, 6x, and 3 goes into 3, 1. And as one of our choices, you can see it, one of our choices is 2x squared minus, oh, it's a 3. See, aren't you glad a math teacher's helping you do this math? So minus 3x minus 1. So that's option C. Okay? All right, since we're with algebra, let's do, we have a problem?
This one, Shaquita from East Wake.
All right, we have a question coming in from Shaquita from East Wake with Mr. Jorgensen. It's an Algebra 2 problem, problem 6. So let's go ahead and look at that. Since you may or may not be able to see it, I'm going to show this to you again. We're going to operate with algebraic expression, polynomial, rational, complex fractions to solve problems. So we're looking here at problem number 6. Let me just grab my notes too. Now, one of the things you have to do when you look at this is you have to be sure that you understand what's going on in this problem. Okay, Shaquita? First thing is, it looks kind of scary when you first start off. You've got 5 plus 2 over x minus 1, all of that over 2 minus 5 over x minus 1. So you actually have several problems going on here. There's a complex fraction in there. So what we need to do is simplify our life a little bit so that we can understand the question better. Now, I like to do this in 2 ways. treat that numerator like a separate problem, like it's its own little family, and then I want you to treat the denominator like it's its own little family, and then we'll put the whole problem back together, okay? So the first thing we need to do, if you were just to treat this top part, the numerator, as its own separate problem, what would you have to do? Well, recall fractions. If you add fractions, you have to have a common denominator. Doesn't matter if there's a variable there, the math is still the same. So what would be the common denominator? Well, in this case, it's going to be x minus 1. Every once in a while, you might want to put those parentheses there to keep that family together. So the rule says the only thing you're allowed to do to a number is add 0 to it or multiply by 1. So our common denominator, we're going to multiply 5 by x minus 1 over x minus 1. That's 1, right? That's perfectly legal. All right, so we'll do that plus 2 over x minus 1. We have our common denominator. I'm going to multiply this. I'm just doing the numerator right now. So 5x minus 5 plus 2 all over x minus 1. Simplify your common terms. So you have 5x minus 3 all over x minus 1. That's our new numerator. Okay. Now let's look at our denominator. We have 2 minus 5 over x minus 1. Again, what do we have to do? Find a common denominator. Common denominator in this case is going to be x minus 1. So we're going to multiply the 2 by x minus 1 over x minus 1. Why? Because you can only multiply by 1. You can't change a number. You can't just randomly throw things in there. So 5 over x minus 1. I'm going to distribute 2x minus 2 minus the 5 all over x minus 1. Simplify our like terms again, and I have 2x minus 7 over x minus 1. Okay? So that is our new denominator. So let's put this all back together. I have 5x minus 3 over x minus 1 all over 2x minus 7 over x minus 1. That's still scary looking. Well, what does this mean? This means division. So let's write it like a division problem. 5x minus 3 over x minus 1 divided by 2x minus 7 over x minus 1. Old-fashioned division. Now, what was the rule with fractions and division? Can't do it. If I gave you 2/3 divided by 5/7, you can't do that. What do you have to do? You have to multiply by the reciprocal. The rule hasn't changed. The numbers have just gotten a little more complicated. So we're going to protect our families. Never want to split them up. Got to keep them together. We're going to multiply by the reciprocal. 5x minus 3 over x minus 1 times the reciprocal, x minus 1 over 2x minus 7. Now it's just straight multiplication of fractions. What's the rule? You multiply numerator to numerator or cross-cancel if you can. And we certainly can in this case. We can cross out entire families. Now don't be tempted to take this 2x and the 5x. They're protected. They all have to stay there together. So final answer, 5x minus 3 over 2x minus 7, which should be choice B. All right, thank you, Shaquita. If you have any other questions, just give me back a call. Any other questions? All right. Well, we've done a couple algebra. Let's look at a couple geometry. If I can find my geometry. Here we go. Geometry was one of my favorite subjects, and I know some of you are wrinkling your nose, but actually it's pretty fun because it's our application of Algebra 1, which everybody loved. So let's look at problem 1. We're going to be doing goal 1. The learner will perform operations with real numbers to solve problems. Use trigonometric ratios to model and solve problems involving right triangles. So problem 1. From the top of a building 50 feet high, the angles of elevation and depression of the top and bottom of another building are 19.7 and 26.6 respectively. Look at that again. From the top of a building, you have to visualize we're doing geometry. Grab some paper.
But you can hear the explanation? Okay. All right. Thank you so much.
So if I'm looking at this problem, I'm going to draw a rectangle for my first building. And I'm going to mark that as 50 feet high. Oops, 50 feet high. Next thing, it says, from the top of a building 50 feet high, the angles of elevation and depression. We have to remember what that is. Let me go off to the side. If I was standing somewhere and looking straight ahead, my angle of elevation is going to be if I was looking up into the sky, looking at we'll call that a plane, okay? You're looking up to it. My angle of depression would be if I'm standing there, line of sight, look straight ahead, I'm looking down at a little bug, okay? Or a big bug, because that would kind of scare me. So there's your angle of depression. So you need to be sure that you keep straight what those are. So looking at our building and looking at our problem, it says from the building, the angle of elevation to the top of another building, which means here I am, I'm going to dress in blue. Here I am looking up to another building, okay, based on my line of sight. So the next building is definitely taller, we know that much. Okay, so we're looking up based on the line of sight, and actually probably should do it from my toes like I'm lying there on the ground, okay, versus straight ahead. So that angle of elevation is what? And I'm going to just draw an arrow, I'm not sure if you can read that, is 19.7 degrees.
Thank you.
Next part of it said angle of depression. That means I'm looking down at something at the bottom. So I'm looking to the bottom of the other building, and my angle of depression is right here, and it says it's 26.6. Well, that may or may not help us. One of the other things we know is since we have parallel lines, as if you're looking straight ahead, and the ground is, of course, always straight, at least when you do these problems, you have to pretend everything's straight. This is also the angle of depression. Why? Because if lines are parallel, then alternate interior angles are, you got it, congruent. All right, so this angle right here is 26.6 degrees, of course. All right. So the question they wanted us to answer, there's two questions on here. It says, what is the height of the second building and how far away is the building? Well, if you look real closely, you can see that you have two triangles going on here. This top triangle, and what type of triangle is it? It's a right triangle. Why is it a right triangle? Because whenever you do application problems like this, the ground is always perpendicular to the building. The flagpole is always perpendicular to the building. The tree is always perpendicular to the building. Even if it's leaning, when we do these problems, we make it perpendicular. So we actually have two right angles. As soon as you have right angles, I need you to start thinking Pythagorean theorem, special 45, 45, 90, 30, 60, 90, trigonometric ratios. I need you to start rolling through your mind some of the things that go with right angles. All right, so one of the things we need to know is we need to find out how far away is the other building. So that's this distance right here, x, and that's also the same distance down here. And the other thing we want to know is how high is the second building. And we'll call that whole height y. Now we already have a head start because we know part of it is 50. Okay? So if we could find this top part up here, and I'll call that z just so we have something to call it. If I can find this top part z, I could add it to the 50. And we have our whole height of our building.
We have a list of problems that we're going by.
So what I'm going to do is I'm going to start with actually problem B. I want to see how far that x is, because the more information I have with each one of my triangles, the better off I
Let
am.
me see if I can find one on the Pythagorean theorem, and maybe it'll be like the one you're doing. How's that?
All right, so let's look at this red triangle, this pink one that I have. I have a right angle, and I've pulled out the information I need. I don't need to see that building right now. I just need to look at this information. And what am I trying to find? I'm trying to find this distance x, and I know 50. All right, so what I always do is I circle the angle I have, and I look at the information. If you have an angle, and you have at least one side, you can do some trigonometric ratios. What do I have? I have the side opposite the angle, and the side adjacent to the angle. Well, remember your trig ratios. Sa, ka, to. If your teacher taught you that, which one uses opposite and adjacent? Tangent. Okay? So the rule is the tangent of some angle is equal to the opposite side over the adjacent side. Your trigonometric functions are just ratios, okay? The tangent of what angle? Well, the angle we have in this problem is 26.6 degrees is equal to its opposite, which is what? 50, over its adjacent side, which is what? X. All right, using our law of proportions, I'm just going to swap our means. So I get, x, that's a fancy x there, equals 50 divided by the tangent of 26.6. All right, so now we're just going to go push this into our calculator, right? All right, well, I'm going to switch over to the calculator real quick. And I turn it on. And one of the things I want you to remember, and this is very, 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 very important, when you first get to the EOC, one of the things that's going to happen is that they are going to automatically reset your calculator. They're going to clear the memory, okay? So the mode that shows up when memory is cleared is this default screen right here. This is for the TI-84, but it shows up the same on the TI-83 or 83 Plus. This is your default screen, and what we're concerned about is this third one down, radians. Do you know what a radian is? Well, you may or may not, but you haven't worked with radians in geometry, and if you have, it wasn't part of what you were doing, so we're going to switch that to degrees. Very, very important. Think to yourself, I need to put myself into the right frame of mode for doing geometry and doing this test. Okay, we quit out of here. Now you can go ahead and type in your numbers. So 50 divided by the tangent of 26.6. The other thing I want to do is I want you to remind you to close the parentheses. It doesn't matter on this problem, but later it might matter when you're adding extra numbers in. Enter 99.84. So we're going to go ahead and round that. That x is about 99 point, and I'll say 85, around to the nearest hundredth. What did that represent? Well, that represented the distance between the buildings. Okay, so now I know what this distance is right here. Oh, sorry about that. So when I typed that in, I got 99.85, and that told me that was the distance between my two buildings. Okay, so this was the angle, so now I have 99.85. All right, well that value carries up because the buildings are standing straight. We're not finding the distance between the Leaning Tower of Pisa and some other building, right? So it's not an angle. So the next thing we need to find out is the distance of the entire building. Well, to do that, I said we want to find this little distance z. All right, so I'm going to pull out that blue triangle. Again, sometimes you just need to pull the picture out so it's not so ugly to work with. I'm going to pull out that triangle. Here's my angle. My angle was 19.7. I'm trying to find this value z, and I know this value here, 99.85, based on the last part of the problem. All right, so we're going to, our angle. Here's our angle. What do we know? We know something opposite, something adjacent. What uses opposite and adjacent? Tangent. Okay, so this is a tangent problem again. Tangent what? The tangent of an angle equals the opposite side over the adjacent side. Write down the geometry, now focusing on the algebra. Tangent of what angle? In our case, it was 19.7. Is equal to the opposite side, z, which we don't know, over 99.85. Okay. To solve this one, I'm just going to cross multiply, makes it look easier. So z equals the tangent of 19.7 times, oops, it's touching my foot. Let's move it over. Times 99.85. All right, so let's go back to the calculator, type that in. Tangent of 19.7, and this is where I really need you to close those parentheses, otherwise you're going to have a very big number, times 99.85 equals 35, z is about 35.75. And is that the answer to the question? No, please, 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 always go back and read the question. What is the height of the second building? All we found was how much higher it is from the other building. So we're going to take that 50 and we're going to add the 35.75 to it. And our total height of our building, this is part B actually. So the total part of our building, we'll add 50 to this. Is approximately 85.75. And units? Well, our problem was in feet, so you always want to end with, in this case, feet. Okay? All right. Any other questions?
Angelica from East Wake wants a Pythagorean theorem problem.
All right. Angelica from East Wake in Miss Staples' room. Let's look for a Pythagorean theorem problem. Let's see. I'm looking at my list. I don't know if you have it in front of you yet. So on a work problem 13. This will be a combination problem of Pythagorean theorem and our other favorite topic with right triangles, geometric mean. Let me just find my notes. All right, Angelica, I'm not sure if you have this in front of you, so I'm going to show you this problem right here. It says, given triangle ADB, this big triangle right here, it's telling us that two of the angles, angle DAB and angle ABB, C, B are 90 degrees. If they're 90 degrees, they're right angles. It also told us something about side AB being 19, and I must have typed that twice. AB is 19, just want to be sure you know that. And AC, this value right here, is 9. Now I'm going to go ahead and draw this because it's going to be important for us to make some marks on here. Let me get some paper. And I'll enlarge it for your viewing pleasure. D, A, B, and it has this line drawn down to be C. So always draw the picture and mark your given information. We have a triangle. It said the angle of DAB is 90 degrees, so it's a right angle. And the measure of angle ACB is also a right angle. Again, as soon as you have right angles, I need you to think Pythagorean theorem. I need you to think special triangles like 45, 45, 90, 30, 60, 90, trig ratios. And in this case, looking at this picture, something that should trigger in your mind is geometric mean. The other information it told us is that AB is 19. And it told us the value of AC, this right here, is 9. Now, what is that called? Think in your vocabulary, an altitude. Altitude, that's very important. When it goes from a vertex perpendicular to the opposite side, it's an altitude of a triangle. All right, so I have enough information, and what are we trying to find? The information we're trying to find in this case is the value of DC. Now, for me to get to DC, I'm going to end up doing some Pythagorean theorem to get there. There are a couple rules. Pythagorean theorem, what is that? Well, you've probably heard it as a squared plus b squared equals c squared. That's only a true statement if you make sure you say that c squared is the hypotenuse, okay? Because sometimes they can trick you and mark the variables different. So it's the leg squared plus the leg squared equal to the hypotenuse squared. Try to keep focused what it really means. Don't just try to shortcut it. So in our case, if I'm looking at this first triangle, I'm missing this piece of information. I'll just call it y. So I could use Pythagorean theorem to find CB. Well, do I need CB? Well, if my goal is to find this value over here, DC, which I called x, how can we ever find that? Well, we only have two pieces of information. We don't have an angle, so we can't do trig. Oh, geometric mean, okay? There's two theorems that are very important when you see a triangle that looks like this. When you drop an altitude to hypotenuse, you've divided it into three similar right triangles. Now, we could set up some proportions and do all the proportions, or you can remember two simple theorems. The one that I'm going to use says that the altitude of a right triangle is the geometric mean. And what's geometric mean? Geometric mean is when that numerator and denominator and those proportions duplicate. Altitude is the geometric mean between the two parts of the hypotenuse. Well, DC is one part of the hypotenuse, and CB is the other part of the hypotenuse. So if I can find CB, then I can find DC. And a lot of times this is going to happen on some of your problems on the EOC is that you're going to have to do more than one step to get to your final answer. All right, so let's look at this triangle A, B, C. What information do I have? I have a leg, and I'm looking for another leg, and I have a hypotenuse. I always think it's helpful to mark the hypotenuse so you know which one is which. Okay? So we could call this one A, so we'll say 9 squared plus the B squared, which is the other leg, y squared, equals 19 squared. We go ahead and do that math. 81 plus y squared equals 192, to memorize all my numbers. Subtract 81 from both sides, I get y squared equals 280. How do you solve for the y squared? We'll take the square root of both sides, so y is equal to the square root of 280. 280 is not a perfect square. If I type that into the calculator, I switch over real quick. Square root of 280 works out to be 16.733332. Doesn't matter. It's not an exact answer. Unless they've told you otherwise, I want you to look for exact answers. The other thing I want you to do is, well, this problem doesn't have any choices for you, but on the EOC, if they've given you decimal answers, they might be numbers that you can round on the calculator. If they've given you radical answers, square roots, then the numbers are more exact. So one of the things you're going to have to do on this, have I switched back? There we go. One of the things you're going to have to do is you're going to have to simplify this radical. I like to do it doing a factor tree. Sometimes is the easiest way. 28 times 10, 4 times 7, 2 times 5, 2 times 2. Have you ever seen this where if you have a grouping that match, a pair that match, that's what can come out. They have a date so they can go out. So the 2 comes out, And if anything else has a date, 7 doesn't have a date, this other 2 and this other 5 don't have a date, so they stay home. So it would be 2 radical 70. Okay? If we multiply 7, 2, and 5 back together. So the value of y is 2 radical 70. Whew, that's an awful lot of work to get there, but that is an exact answer. All right, now we have this little part of the hypotenuse. So now we can substitute back in to get what we need for this value DC. So 9, the altitude, is the geometric mean between what? Between the first part of the hypotenuse, this DC, and the second part, 2 radical 70. You have a proportion, so cross multiply to solve. So I get 81 equals 2 radical 70x. I'm going to switch this. Symmetric property says I can make it look any way I want to in algebra, right? I can switch those sides to make it more comfortable. That's what I want to do. Why? Because I'm going to divide both sides by 2 radical 70, and I want to have enough space on my paper so I can finish the problem. And that's the way I like it. All right, so to get this is an answer. Is it a final answer? It could be, but it's not completely done. If you had ever left a problem with an answer of 2/4, how would your teacher have liked that? Well, it's not wrong, but it's not completely done. Final answer is 1/2. So 81 divided by 2 radical 70 is not exactly wrong, it's just not completely right. You're just not done. You have to rationalize it. To do that, you have to find a way to eliminate the radical. We don't like radicals in the denominator. So one of the things you can do is multiply by 1. And the 1 I choose is radical 70 over radical 70, or square root of 70 over square root of 70. Multiply across. 81 square root of 70 divided by 2. Square root times itself gives you that number. So final answer, 81 square root of 70 over 140. And none of that reduces. And that is an exact answer, and you could type that into your calculator. And that is the value of x. So I hope that helped out, Angelica. All right, thank you. We have another problem from Shaquita again. It was East Wake, Mr. Jorgensen's class, Algebra 2, Problem 5. Yeah, let me see this real quick. All right, Algebra 2, Problem 5 is an addition and subtraction of fractions, right? Well, they're not real pretty fractions, but that's okay. The rules haven't changed, just the numbers changed, okay? So let me write down the problem. And this goal, again, is to operate with algebraic expressions, polynomials, rational, complex fractions. This is a rational expression. Let me write it down. 4x plus 9 over 4x minus 5 plus x minus 3, x plus 1 minus 34 minus 2x over 4x squared minus x minus 5. All right, now, for us to figure out what the common denominator is in this one, because we're going to be simplifying, we're not actually solving for x. We're not going to discover that x equals 10 or x equals 4 or something like that. We're just simplifying the problem as if you had a couple fractions and you added them together. For you to find out what the common denominator is, you're going to need to factor this denominator over here on this third term first, because we need to see what all its factors are so that we're sure that every fraction has the common factors. If we factor this one, okay, if we factor this one, you may or may not know whether you can see the factors or not, so I'm going to take this one off to the side. Four x squared minus x minus 5. And you can do guess and check, but we're just going to do a method that we know always works, okay? Let me put it actually on a clean piece of paper. And I always call that the AB, or AC plus B method, okay? What's A times the C term? That's negative 20. And what's the B term? Negative 1. So I need two numbers that are going to multiply to give me negative 20 and add up to give me negative 1. So those numbers would be negative 5 and positive 4, correct? Negative 5 times positive 4 equals negative 1. And negative 5 plus 4, or times 4, gives us the negative 20. So split up your middle term. I'm not really doing anything wrong, I'm just splitting up a term. It's like splitting up $1 into quarters or something. So 4x squared minus 5x plus 4x minus 5. I haven't changed anything. Next thing you want to do is group the first two and the last two, and then find the GCF for each one of those terms. So I'm going to factor out the x. I'm left with 4x minus 5 plus, well, there is no GCF here. Well, everything has a GCF. If in doubt, you can factor out 1, right? So I'll factor out a 1, so that's 4x minus 5. Now, the parenthesis is a common factor. You can pull out a common factor that is a grouping, so 4x minus 5. And then I always cover it with my fingers, and whatever's left over happens to be the other grouping, x plus 1. So those are the two factors. That is this quadratic factored out. Okay, so let me pull it over to our original. There we go. All right, so I'm just going to kind of cross that off so I can see. So now we're back to the guts of the problem, which was what's the common denominator. If you notice, this first term has 4x minus 5, the second term has x plus 1, and the third term has both of them. So one of the things I do to make my life easier, and the way I think about it, is you want to give the factor to the term that it doesn't have. I don't know if that makes sense, but let's look at it. So the first one doesn't have the factor x plus 1, so that's the value that we're going to need to multiply by so that it will have that factor. The second one does not have, the second term does not have the 4x minus 5 as a factor, so we're going to multiply that in there. I'm going to squeeze it in, and I'll rewrite this so you can read it a little bit better. Hold on. Okay? So now I actually have two separate little problems, okay? So I'm going to try to keep this problem pure so we can see what's going on. And let's multiply this one, this first term. So that's x plus 1 times 4x plus 9. What do you need to do? You need to do distributive property. So 4 times x is 4x squared. X times 9 is 9x. 4 times 1 is 4x. 1 times 9 plus 9. Combine your like terms. Okay, so that's our new numerator for this first term. So I'm going to rewrite it here. 4x squared plus 13x plus 9 over, and we know the common denominator already. The common denominator is 4x minus 5, x plus 1. And I'm not going to multiply that out quite yet. Next thing, I need to distribute this second term. So x minus 3 times 4x minus 5, 4x squared, x times negative 5 would be negative 5x, negative 3 times 4x would be negative 12x, and negative 3 times negative 5 is positive 15. Combine like terms again. That's our new denominator, our new numerator for this term. So plus, here's your plus. Pull this over. 4x squared minus 17x plus 15. Whew, still not done. Now we need to add in, and I didn't write down I think it got lost in my work over here, but if we look at this was problem 5, that's subtraction right here. Okay? Actually, I'm going to change the color so you can see it. Shafida, that's subtraction. Well, you have to treat this like a family. You can't just subtract one of the numbers, you're subtracting the whole numerator. So when I subtract, I need to almost think of that as plus and negative 1 being multiplied in there, and we'll distribute that negative. So negative 1 times 34 would be negative 34, and negative 1 times negative 2x would be positive 2x. So that's our new numerator after doing all that. Now we have to try to simplify. So if I go through and combine my like terms, I have 8x, I have a 4x squared, a 4x squared, and that's all I have, so I have 8x squared. So I'm going to kind of cross those off just so I know they're gone. I have a 13x, a negative 17x, and a positive 2x, which will leave me with negative 2x. And I'm going to cross those off, make sure I get them all, I don't want to lose something. And I have 9 plus 15 minus 34, which leaves me with negative 10. All of that over 4x minus 5 times x plus 1. Are we done? No, you're not done. Because now we have to see if we can get anything else to reduce. Just like a normal fraction, you have to always keep reducing. So if this answer had shown up on the EOC, which it probably wouldn't, or any one of your tests, again, it's not completely done. If you had a fraction like 2/4, it's not done. You have to keep reducing. So I'm going to focus just on this numerator right now. Get another piece of paper. Plan a tree after this test with all the paper we're going to use. So 8x squared minus 2x minus 10. How can we factor that? First thing you always do is look for a GCF. What do 8, 2, and 10 have in common? They have a 2 in common. So we'll factor out a 2. So you're left with 4x squared minus x minus 5. Does that look familiar? It should, because it looks just like that original denominator we had. Okay, so that's nice. So we can factor, we don't even have to factor that because we have that work already left over for us. So it becomes 2 times 4x minus 5 times x plus 1. So that's our new numerator. Let me transfer that over here. It's off your screen, but I can see it. So 2 times 4x minus 5 times x plus 1 all over 4x minus 5 over x plus 1, and this is the best part. Everything wiped out. Isn't that great? Final answer? 2. That's awesome. It's like a puzzle when you do these kind of problems. Everything canceled each other out. Final answer was 2, which on this multiple choice, I believe, was option D. Okay. I hope that helps out. All right, thank you. James from East Wake, Ms. Hare's classroom wants geometry problem number 2. So let me find my list of problems. And again, since I'm not sure what you all have in front of you right now, let's look at problem 2. This is still in that first goal, James, which was using trigonometric ratios to model and solve problems with right triangles. So if we look at this, I have A, B, D, F is a rectangle, and both the triangles DEF and BCD are isosceles. I'm going to redraw this for you real quick. I wish I had a ruler. Well, guess what? On the EOC, you don't get any rulers. If they had described that problem to you, you're going to want to draw it to make it as accurate as possible. So here's a trick I want you to do. They're going to give you graph paper. You're allowed as much graph paper as you want. Raise your hand, say, I would like more graph paper, please. And I want you to take that graph paper, and I'm actually not going to fold it all the way. Rip it. Doesn't have to be pretty. You're going to fold it, and Shazam, look at that. What do we have? We have a folded piece of paper. No, you silly, not a folded piece of paper. What we have is a straight edge, okay? This will help us, and of course I should probably just be drawing the picture that we were going to do. This will help us draw and look. Oh my gosh, it's a rectangle so that we know both my sides have to be the same, right? Not only is it a straight edge, but it's a calibrated straight edge because it's graph paper. And I'm going to make it exactly the width of the graph paper so I don't have to work too hard. There we go, and I can use my straight edge. Look at that. Now, it's taking me a lot longer to do this because I'm explaining it, but it'll be very easy for you to do on the test. Next thing is you need to create the 2 right triangles. The more accurate your drawings look, the easier it will be for you to do the problem. Okay? So there's our problem. We mark the vertices. That was A, B, C, D, E, and F. And it told us this value was 15. The value of DB was 7. And that's all the information we have so far. Okay? Now, I'm going to come back to this little cheaty ruler here in a second because this is a great tool. All right. The question was, what is the perimeter of A, B, C, D, E, F, the perimeter of the entire picture, and what is the area of the entire picture? Well, you have to know what perimeter and area are, James. So perimeter, I know you can't answer me back, but perimeter is the distance around. You have to add it up. So what am I missing? I'm missing FA, I'm missing AB, I'm missing a lot of these values, okay? So what we need to do is we need to go through and see if we can find any of those values. Well, the fact that it's a rectangle, what do we know? Opposite sides are parallel, opposite sides are congruent. All right, so this is 15, this is also 15. This piece right here, DB is 7, so is FA is also 7. So we just found a couple. So now we need to focus in on these triangles. Okay? Well, one of the pieces of information it gave you in the problem is that these two triangles are isosceles. So if I mark these as isosceles, isosceles right triangles, isosceles right triangle, ping! What should go off in your brain is 45, 45, 90 triangles. Now, if you don't remember the pattern, you can always use Pythagorean theorem to solve it. But if you do remember the pattern, one of the things that you know is that a leg is equal to the same value as the other leg, and the hypotenuse is equal to what? The leg times radical 2. Well, we have the hypotenuse, so what if we put it into that equation? What if we say 15 equals the leg, mystery value, we don't know. Here, we'll just call it x, so we have a value. X times radical 2. Divide both sides by radical 2. So x equals 15 divided by radical 2. Again, we can't have our answers like that. We can't have radicals in the denominator, so what do we need to do? We're going to rationalize 15 radical 2 times radical 2 over 2 equals 15 radical 2 over 2. So that's our value over here. It's the value of FE. It's also the value of DE. Oops, over 2. Now don't get distressed about how ugly the numbers might be, James. It's okay. The numbers are numbers. Now since it didn't ask for an approximation, these values are exact. Look at your answers in the EOC. I think I said this before. If there's decimals out there, then you're going to be able to type that into the calculator and round it. If the answers are in radical form, then they want exact numbers. That's an exact number. All right, so we need to do the same thing with triangle D, or BCD. Okay? Let me do that in a different color so we can see the difference. So again, it's a 45, 45, 90 triangle. So what do I know? I know the hypotenuse is 7. So 7 equals the leg, which I'll just call y. Y times radical 2. Divide both sides by radical 2. I'm left with 7 radical 2 equals y. Rationalize means multiply by the same square root in this case. Did I just hit a button? Well, if you can't see me, let me know. So 7 radical 2 over 2. Now, if you can remember, there is a shortcut if you can see this pattern. I'm not going to say it because I don't want to confuse you, but if you see the pattern of rationalizing very quickly, it's the hypotenuse times radical 2 divided by 2. I don't want you to memorize something else at this point, if it's too late, but if you see the pattern, that'll speed up your life. If you forget this entire pattern, you can always do Pythagorean theorem because these two legs are the same. You just have to go through a little bit longer. All right, so 7 radical 2 over 2. 7 radical 2 over 2. I have all my sides, so I can add them up. How can I add those up, you say? Well, just go around. 7 plus 15 plus 7 radical 2 over 2 plus another 7 radical 2 over 2 plus a 15 radical 2 over 2 plus a 15 radical 2 over 2. And I'm back where I started. All right. Add those up. Well, the 7 to the 15 won't be too bad. We have 22 here, but how do you handle these radicals? Well, these are fractions. Fractions, you would add the numerator, keep the same denominator. 7 radical 2 over 7 radical 2, treat it kind of like a variable. If I'd given you 7x over 2 plus 7x over 2, wouldn't you have said 14x's over 2? Well, the same thing here. So plus, then I wrote it down the wrong number, 14 radical 2's over 2 plus, 15 radical 2, 15 radical 2, 30 radical 2's over 2. And again, I can put these, I should have done that in the first case, but that doesn't matter. So 22 plus 14 plus 30 would be 44 radical 2 over 2. Whew, that's a valid perimeter.
Yes,
Okay?
that would be wonderful. Okay.
And that was part A.
Ocean,
All right, part B. I just did all that. All you did was find perimeter. Now we have to find the area. Now the area of this entire shape, well, do you happen to know the formula for the area of a, I don't know what that could be. It looks like kind of a house that tipped over with its garage attached. There's no formula for that. But one of the things you can do is take a picture, and this one happens to already be cut up for us. take the different areas, add them up, and you get the total area. So if we took the area of this first triangle, FED, area of this rectangle, FABD, and the area of this triangle, BCD, we can find the area of the entire shape. Now, one of the things I would recommend is that you write yourself a little recipe, okay? So I'm going to have to redraw my picture. See, did my one with the cheaty ruler look much better? A, B, C, that was the right angle. D, E, F. And I did have some values in there. We know that, actually we had all the values, didn't we? 15, 7, 15, 7. We just found with the work we just did that these values right here were 7 radical 2 over 2. We might need that. 7 radical 2 over 2. This was 15 radical 2 over 2. 15 radical 2 over 2. Now, if I'd been smart, I probably would have put my picture on a different page so I could have had more space to work with it. All right, area. We take the area, and I'm going to make it blue so you can see it. The area of this blue triangle. And we add it to the area of the rectangle. And then we add it to the area of this pink triangle. We'll get the total area. So there's our recipe. Now we have to do each part of the recipe. How do you find the area of the triangle? This is one of those formulas that you need to know. Okay? In fact, you're going to need to know a lot of your formulas. None of them are given to you on the ESC this year. So the area of a triangle is equal to 1/2 base times height. Okay? Oops, this was a right triangle right here. Shortcut. If it's a right triangle, your legs are your base and your height. Sometimes you get a picture turned around and you get all caught up on trying to find a height with a right triangle. You don't have to go there. Just turn the picture, and this one's already turned for you. Look at your two legs. Your legs are your base and your height. So for this first blue one, and I'm going to do it off to the side just so I can keep things nice and neat. So the area of the blue triangle would be 1/2. The base is 15 radical 2 over 2 times the height is 15 radical 2 over 2. Multiply those all together. 30 radical 2, not 30. 225, we have to multiply, not add. Radical 2 times radical 2 would be 2 over 2 times 2 times 2 would be 8. You can simplify at this point and make your numbers just a little bit smaller. So 225 divided by 4 is what? I should know that off the top of my head, shouldn't I? No, it doesn't reduce. No. Well, that's good for now. That's as far as we have to go on that one. All right, area of the rectangle. How do you find the area of a rectangle? Area of a rectangle is base times height, or length times width. We happen to know that. 7 times 15. 7 times 15, that was a pretty easy recipe to do. Let me write in the values I have. 225 over 4 plus the area of the rectangle. 7 times 15 is 105. Now we have to find the area of the pink triangle. Okay, so the area of the pink triangle would be what? 1/2 base times height. 1/2 base was 7 radical 2 over 2. Height is 7 radical 2 over 2. Multiply 49 times 2 over 2 times 2 times 2, 8. Gives us 49 over 4. Can we do that? Sure we can. Those are just normal fractions. You can handle this now. So we need to find a common denominator. Or you can just type it in your calculator. Calculator on. You sure when you type in your fractions you put parentheses around it so the calculator knows it's a fraction, make your life easier. 2 radical 25 divided by 4 plus 105 plus 49 divided by 4. Now, I'm not saying you couldn't do this by hand, but you have the calculator at your disposal and you need to take the time to do the arithmetic on there. I'm going to let our final answer be, let our final answer be in fraction form. And the final answer would be 347 divided by 2. 347 divided by 2. Now, if on the EOC they gave you decimal answers, you can go ahead and multiply that out. and get 173.5, just all depends. And what did that represent? That represented the area. So if there were units, this problem didn't give us any units, so they might just put on there something like units squared. So always be conscious of that, okay? All right. Thank you very much. Okay. We have Jennifer from Nightdale in Miss Williams' class. She wants an Algebra 1 problem. Algebra 1 problem 2. And that's this one. Simplify this term right here, which is 6x, if y'all can read that, 6x to the 5th, y to the 3rd, over 16x squared, y to the 5th. This is write equivalent forms of algebraic expressions to solve problems. In this problem, we're basically reducing a fraction. Of course, when you reduce fractions that have variables in it, we need to remember some of our exponent rules. In our world of exponents, if you have exponents that are being divided, what's the basic rule? Well, the rule is if we have x to the n over x to the m, it's x to the n minus m. What does that mean? Basically, you're going to be subtracting the exponents. But what we like to do is try to keep the exponents positive. Okay? Now, another way of thinking about this, if you get yourself frazzled and aren't sure which way you need to go, is you could also think of this, and it's going to take me a second to write it, 6x, x, 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 5 of them, right? Over 16, 1, 2. Cross them off. Okay? They cancel each other out. What did I really do? I took 5 minus 2. What does that leave me with? That leaves me with x to the 3rd on top. That's how many are left. Okay? Same principle with the y's. I have 3 y's on top, 5 y's on the bottom. You're going to do subtraction. 5 minus 3 is what? 2. 2 what? Y to the 2. Where does it belong? It belongs in the denominator because the larger exponent was in the denominator. I think that's just an easy way of thinking of it. And again, we could say y. I wouldn't expect you to write this out every time, but sometimes if you just need to revisualize it, that's what you need to do. And then what do? We treat our numbers just like we would always treat fractions. What goes into 16 and 6? 2. 2 goes into 6 3 times. 2 goes into 16 8 times. Final answer would be 3. That's not a decimal. 3x cubed over 8y squared. That's as far as we can go on that one, Jennifer. All right, thank you. Maybe anyone else? Other ones? All right, then I'll pick one more problem. Should we pick something from Algebra 2?
Let's do that.
Okay. Let's pick something from Algebra 2 that won't... How much time have we got?
We have about 7 minutes.
All right, well, let's look at problem 3 on the Algebra 2. Now they're simplifying, so that's our theme for the day. We're simplifying some of these fractions and radical expressions. And this one has something very special. The little tiny I, see you out there. What's little tiny I? It's not little tiny I, it's imaginary numbers. So what is this? These are complex numbers. Oh, look at the goal. Define and compute with complex numbers. So there's a couple things you need to remember when it comes to complex numbers. First of all, you need to remember what the I represents. I represents the square root of -1. Okay? Then you have to remember some of the patterns that go with it. And I always like to remember it. Oops. Oh, that's the problem with pen. Hello. I always like to remember it kind of on a wheel. You know what? Let's try that again. We have I. We need to remember what I squared is. We need to remember what I cubed is. We need to remember what I to the 4th is. I'm dying to write that 4. Okay? I is the square root of -1. I squared, that would be square root of -1 times the square root of -1. A -1, multiply the same radical, you're left with what's underneath, -1. It's pretty powerful. You can take an imaginary number, square it, it becomes a real number. Now, not a real number we like, but -1 is always a bit of a thorn in our side in any of your problems. Take that same pattern, multiply by a square root of -1 again. You get -1 times square root of -1, which is what? Well, -I. So we went back to the imaginary world. Multiply it one more time. It would be -1. Add another one up here. Square root of -1. So we have -1 times -1. And what are you left with? +1. That's awesome. And then it can continue. The reason I like this wheel is what if I asked you what is I to the 7th. And once you have the wheel, you could say I to the 1, I to the 2, I to the 3, I to the 4, I to the 5, I to the 6, I to the 7. It's negative I. And you can reduce it very quickly. Now, of course, you wouldn't want to do that if it was I to the 327th, but we could divide by 4 and get ourselves down pretty small to do that as well. Okay? All right, so that's just one of the things that we have to remember on this problem. The second thing we need to remember are our rules of reducing. Grab some more paper. Or how we simplify rational expressions. And what do we have to do? Well, we have to find common denominators. So let's get started. 3 plus 4i. And I always put parentheses around them because I want to keep those families. I don't want you to think that on this one right here, sometimes they trick you and you think that you can cancel out those i's, and you can't do that. They belong inside. They're a family. Plus 6 minus 5i over 2 plus 2i. Okay? Before we can determine what the common denominators, we need to make sure that both of our denominators are factored out completely so we can simplify. This one, factor out of 2, and what are you left with? 1 plus I. Okay? So if we're left with 1 plus I, then we know that this term over here, what does it ring a bell to me? Yeah, that's right, though. 1 plus 2i, or 1 plus I. So we need to make sure that both of these terms have all the missing pieces. So what does this one need over here? This one needs it needs the whole thing. It needs the 2 plus 2i. So we can multiply that over here. And this one, we can multiply 2 plus 2i, because you can only multiply by 1. And what is this term missing? It's missing the other denominator, which is 2 minus i. 2 minus I. All right, now, here comes the challenge. And what makes this problem challenging is this distributive property up here. So 2 plus 2i times 3 plus 4i, plain old distributive property, right? 2 times 3, 6, no problem. 2 times 4i is 8i. 2i times 3 is 6i. And 2i times 4 would be 8i squared. Okay? 6, combine similar terms. 8 and 6 would be 14i. What do we do with this? This is the key to this problem, because I'm not going to have time to finish the whole thing. That I squared, remember that little wheel I just showed you? What is I squared equivalent to? I squared is equivalent to negative 1, so you need to make that conversion. So this becomes negative 8. Now when you combine similar terms, you have 14 plus 14i. Okay? Now, I don't know how much time we got? 3 minutes? Well, we'll keep going as far as we can on this one, and I'll let you know that the answer is D, so that if we have to end it, I've already given you the answer. Now, that doesn't mean you turn me off now. You have to completely watch this whole problem, okay? All right, so this new numerator up here is 14 plus 14i. And I can still factor out that 2, which I'm probably going to end up doing later on. So now we have to do this numerator over here. 6 minus 5i times 2 minus I. Same issue again. We have to be very conscious of that when we do the FOIL method or we distribute that imaginary number. So 6 times 2 would be 12, minus 6 times I would be negative 6i, negative 10i, and negative I, 5i times negative I would be positive 5i squared. 12 minus, combine similar terms, 16i. What do we do here? Remember we said that I squared is equal to negative 1, so minus 5. 12 minus 5 is, what, 7? Minus 16i, so that's our new denominator, our numerator on that side. It was addition, so add 7 minus 16i all over 2 plus 2i times 2 minus I. Now combine our similar terms. I still have time? Okay, 14 plus 7 is 21 plus 14i minus 16i, or, well, here we go, minus 2i all over, I'm going to factor this one out again, 2 times 2 plus, 1 plus I, 2 minus I think I've made a typo. I have to go back on my problem. Am I right? Where did I make my typo then? Well, I have to check it. No, up here is when I made my problem, right? So I should have ended up with 7 minus 69. Over here I should have had 2, negative 2. Okay? Yes, we can add 6 minus 8 over here because it was negative. Hope you caught that. All right, so minus 2. That makes my life a little bit easier. 14. All right, so we have anything can cancel? Well, actually we have this 2, but this is a family. Oh, we can factor out a 2. All is good. So factor out a 2. We're left with 7 minus 2i. Oops, 1i. The pressure of the minutes. 2 divided by 1 plus I. 2 minus I. The 2's cancel. 7 minus I is the numerator over 1 plus I times 2 minus I. All right, well, I've run out of time, but I made another error over here because that should have been 5. All right, so our final answer should have been 5 minus 2i over 2 minus I. See, we all make mistakes. So what would have happened is this answer wouldn't have been on the EFC. I mean, that would have been pretty simple right there. So I would have had to backtrack, and ironically enough, what are the biggest errors? Arithmetic. And now we're up to algebra 2 because it's trivial to you. All right, so sorry about that, but that is our final answer, and it was my arithmetic right up here. All right, well, I hope you'll see us again. We're going to be here again tomorrow, same time, Friday, from 3 to 4. If you have any questions, be sure you go online and get the rest of the questions. Is that the end of my time? 4?
4 to 5.
Oh, 4 to 5. What did I say? 3 to 4. So 4 to 5. Go to the Wake County website, wcpss.net, to get the answers, or the questions, and I'll give you the answers, and we'll work through it, and you're going to ace the EOC. Thank you.